right, now we're going to do DSMA for exponent rules. There's a lot of exponent rules, and we're going to go through the ones that we need for this class. After you've done the lecture video, the lecture notes, and the homework, if you feel like you need a little more practice, you can go to khanacademy.org. And if you just type in exponent rules, you'll get videos, you'll get practice, because these are really important tools that we will use the whole semester, but inside other problems. All right, the first thing we're going to look at is the zero exponent rule. The zero exponent rule tells us that anything that we raise to the zero power is going to equal 1. And I'll be able to prove that to you when we get to some other rules. But this is an absolute. I can take 5 raised to the power of 0, that equals 1. I can take 100 raised to the power of 0, that equals 1. I can take 7x all raised to the 0 power, that equals 1. It just equals 1. It doesn't matter. And so this one is -3, but it's in parentheses, which means the negative and the 3 are all raised to the power of 0. Therefore, it is 1. So that is the answer. We just need to know that one. It's very important. Okay, so this one is a little tricky. This is just like we looked at when we were looking at order of operations. The negative is not raised to the power of 0. This is really -1 times 8 raised to the power of 0. That negative is not raised to the power of 0. If I had given you parentheses around the -8, then we would just get 1. But since we don't have parentheses, the 8 raised to the 0 power is still 1. However, we have this negative hanging out front. And so this ends up being -1. Okay, it's not breaking the rule. 8 was still raised to the power of 0 and therefore was equal to 1. The issue is the negative sitting out front means that that is not raised to the 0 power, that negative. Only the 8 was raised to the power. Let's look at product rule. Product means multiplication. So if I have x raised to the m power times x raised to the n power, that, and because it's multiplication, we're going to add the two exponents together. So the x stays the same, but we add the two exponents together. Let me show you up here why that works. So we have x to the third power times x to the second power. Okay, since it's multiplication, since it's product rule, that would be x to the 3 plus 2, which means we would have x to the 5th power. Okay, so let's talk about why that works. For x cubed, that would be x times x times x. These are supposed to be times, my stylus. And then for x squared, well, we know we're multiplying. We have x times x. So sure enough, look at that. I have 5 x's. So that is x to the 5th power. Okay, now we don't want to do that if the numbers are really big. Product rule is really important. So if we have a variable raised to a power times the same variable, those variables have to be the same. We can't do x to the third power times y squared. That doesn't work. They have to be the same variable, so have the same base. And if they're multiplied, we can add the exponents together. Okay, then we have power rule. So for power rule, we're raising a power to a power. So notice here, we have x to the m power raised to the n power. Okay, so we have a power raised to a power. If that happens, we're going to multiply the exponents. Okay, so let's look at the problem we have. we have x to the 16th power, all raised to the power of 3. So we have a power raised to a power. That means that we're going to take x to the 16 times 3, and that will give us x to the 48th power. Now, the other way of looking at this is, we'll come down here. This is a completely different way of looking at it. Because it's raised to the third power, we have x to the 16 times x to the 16 times x to the 16. So if we use product rule, because these are all multiplied together, we could just add these up and we get to the same answer. That's the issue with exponent rules, is there's sometimes different ways to attack these problems. But it's very important to have these down. All right, next we have quotient rule. Quotient rule is when we're dividing. Quotient means division. You'll see a fraction. Again, the variables have to match, so the base has to be the same. So if I have x raised to the m power divided by x to the n power, we're actually going to subtract. So when it was multiplication, we added. When it's division, we're going to subtract. Algebra is its own language, isn't it? So let me show you what's going on over here with the y. So let's block this off. So we have y to the 7th over y to the 4th. And so because this is division, we can actually subtract these, and that would give us y to the 3rd power. So just for a visual, let's take a look at this. I know this is crazy. We would not normally do this, but let's go ahead and put 7 of these y's on top. Make sure I did that. 1, 2, 3, 4, 5, 6, 7. Good. And then we're going to put 4 on the bottom. Now notice I could divide some of these out, right? Because like 2 over 2 is 1. Well, y over y is also 1. So I can divide these and get 1, divide these and get 1, divide these, and I'm going to keep going. This is all multiplication. 1 more. Okay, so all of these we were able to divide out, and look what we're left with. 3 y's, which is our answer up here, y to the 3rd power. So that's why it works. Again, we don't want to do that if our numbers get really big. Like let's say I gave you, over here, I gave you x to the 25th over x to the 15. I do not want to write out 25 x's and then 15 x's and start crossing through. But what I can do instead is know that that's how that works. I'm going to subtract 25 minus 15 because I know that 15 of those are going to divide out and equal 1, and that's going to leave me with x to the 10 power. Okay, next we have what's called power of a product rule. And so we can use this rule if we have multiplication inside the parentheses. So notice inside here, I have x times y. And so therefore, I'm kind of distributing the exponent. That's not really how we're supposed to word it, but that's really what kind of happens. We have a power out here of n. So now I'm going to have x raised to the n power. That's going to be right here. And then I'm also going to have y raised to the n power, but it's still multiplication. So remember, a product is multiplication. It's going to stay multiplication. But then at that point, we might have to clean it up a little bit. So let me block this out and let's take a look what we have here. So we have 5 times y to the 4th inside. So that's a product. It's multiplication. It's 5 times y to the 4th power. And that's all squared. So what we're going to do is square each piece. That means, so I'm going to kind of separate these out. I'm going to have 5 squared, and then it's still multiplication. And then I'm also going to have y to the 4th power all squared. Okay, so I pseudo-distributed that exponent of 2, and I distributed it to the 5. I also distributed it to y to the 4th. But now I have to clean it up. I can't put the answer in looking like this. So we know 5 squared. 5 times 5 is 25. Now with the y, we have power rule here, right? This is power rule. We have a power raised to a power. And so this would be y to the 4 times 2. Therefore, our final answer would be 25 y to the 8th power. Now, we could have done this problem a little different way. Let's do that over here. Because it was 5y to the 4th power all squared, the square tells us we need this twice. So we could do 5y to the 4th times 5y to the 4th. And then we could just straight multiply. So 5 times 5 gives us 25 because everything's multiplication. Remember, if you see parentheses with no addition or subtraction, it means multiplication. So 5 times 5 gives us 25. Y to the 4th times y to the 4th, we would need to add those exponents. And so we would get 25y to the 8th. So that's what I mean. It's really good to have these rules down, but a lot of times there's different ways that you can attack the problem. All right, so these are starting to look a little crazy, but they're still the same rules. So once you have those rules, it doesn't matter what the problem looks like. You can work your way through it. So we notice that we have a 3 here on the outside. So if we look on the inside, we can see that it's all multiplication. So since it's all multiplication, we can use power of a product. So we're going to take each of those 3 pieces and raise them to the power of 3. So I'm going to take -2. The parentheses are very important. If you're raising a negative to an exponent, you have to have parentheses. And then we've got x to the 3rd power raised to the 3rd power, and finally y squared raised to the power of 3. So basically I took the 3 pieces, I took -2, x to the 3rd power, and y squared, and I raised each of them individually to the 3rd power. So with the numbers we always just can put in our calculator. Don't put the x's and y's in the calculator, but you can put the number. -2 times -2 times -2 would give me -8. You also could raise it to the power of 3. Now we need to use, because we have powers raised to a power, right? We have x to the 3rd power raised to the 3rd power. We actually need to use power rule here. And that means we're going to multiply. So 3 times 3 would give me 9. So I would have x to the 9th power. Y squared raised to the 3rd power. Again, I'm going to multiply. That would give me y to the 6th power. So whenever we raise a power to a power, we're going to multiply. Okay, another crazy looking one. But this is all multiplication. I know you see negatives, but those are negative numbers. There's nothing in front of it, so it's not subtraction. All right, so me personally, I like to move all of the like items together. So I'm going to come over here and I'm going to put -3 times -8. I'm going to put the x's together here. X to the 4th times x to the 8th. Stylus is acting up again. I apologize. And then y to the 1 times y to the 10th. So remember, when we do not have, if you don't see an exponent, there's an implied 1 there. And that's very important with exponent rules, because otherwise, if you're just looking at y times y to the 10th, and you don't grab the implied 1 that's sitting here, of course, it's going to be wrong. All right, so let's multiply. -3 times -8 is going to give us a positive 24. Very important. Negative times a negative gives us positive. For x to the 4th times x to the 8th, we're going to use product rule. Product rule tells us that we're going to add the exponents together. So we have x to the 12th power, and then Again, we have product rule, y to the 1 times y to the 10th, and that's going to give us y to the 11th power. And then you get to type all of that into the computer. Now, again, with these, make sure when you're typing these into the computer, you're going to type the 24, you're going to type the x, and then there's an icon along the bottom of the screen that looks like that. So you're going to, after you type the x, you're going to hit that button and put the 12 in, but then you have to hit your right arrow key because otherwise you're not going to be down where you need to be for the y. And that's very important. You don't want the y up in the exponent with the 12. So use that right arrow key to come out of the exponent and come back down to the normal line there. Now, when these problems get more complicated, we have to really be careful that we take care of the numbers differently than we do the variables. The numbers are not subject to exponent rules. Well, unless you see exponents on them, but normally when we're dealing with numbers. So the numbers can actually go in the calculator. If you want, you can just put 63 divided by 7 in your calculator. Just don't put the x's because that'll give you an answer, but it won't be the right answer. So we want 63 over 7. That gives us 9. And then this is actually a quotient rule, right? Because we see that we have division, we have quotient rule. So we are going to subtract the exponents, 5 minus 2, and that gives us 9 times x to the third power. And that's it. All right, new concept, negative exponent rules. So normally we don't allow negative exponents, and so you need to move them around and make sure they become positive exponents. But it happens that sometimes in the middle of a bigger problem, you're working and you end up with a negative exponent. Well, then you just need to move that exponent. So what happens, let's say we get this, we get x raised to the negative m power. This is about what we call reciprocals. Reciprocals are like 2/3 and 3/2, right? Those are reciprocals. We flip them basically so that the denominator becomes the numerator and the numerator becomes the denominator. So this is the same idea. What's going to happen is because this is a negative m, we're going to move x to the m power down to the denominator, and then the exponent becomes positive. So as soon as we move it, it becomes positive. And so a negative exponent really is about movement. Oops, I've got this one wrong. This is supposed to be positive. All right, so if the x is in the numerator, and of course you might not see the 1 underneath it, then when you see a negative exponent, you're going to move it to the bottom, like this first one. If the x raised to the negative power is in the denominator, then we're going to move it up to the numerator and it's going to become positive. So let me give you an example. So let's say I had x raised to the negative 2 power. Now technically this is over 1. We don't write that, but that's really there. It's implied. So because I have a negative exponent here, that tells me I need to move the x squared to the bottom, but I still need a placeholder up here, so I have to leave a 1 up there. Okay, so the x to the negative 2 power told me to move the x squared to the denominator. The negative exponent now gone because I moved it, and now I have 1 over x squared. All right, let's try another one here. Let's try 1 over x to the negative 3 power. Okay, so since the negative exponent and the variable are in the denominator, we are now going to move it up to the numerator. So x to the third power is going to move up there. Technically, I'm going to have a 1 on the bottom, but we don't leave that. And so that would leave me with x to the third power. Okay, so let's come over here and look at our problem. We have x to the negative 5th power, and we have y. Okay, well, the x is raised to a negative power, but y is not. So y can stay put in the numerator, but that x to the 5th power is going to have to move to the denominator. And now that we've done that, now that we've moved it, we have to check and see if we can clean anything up, but we can't because we have two different variables here. We have a y raised to the power of 1 in the numerator, and we have an x raised to the power of 5 in the denominator. So we can't use our rules when we have different bases. So we are actually done with this one. Okay, but this problem we have a few choices. The negative exponents still work with all the rules. We can have negative exponents. We can have fractions as exponents. I know you don't want to hear that. We can have decimals as exponents, and all the rules still work. So we have a couple choices. We could go ahead and take care of the negative exponent and move it, or we can use power rule first. So that's what I'm going to do. I'm going to use power rule. Power rule tells me that if I raise a power to a power, I multiply. So this tells me I need -2 times 7. That gives me x to the -14 power. Now, if I put that into my math lab right now, it's going to give me that red box that says, although it's the correct answer, it is not in the correct format. And that's because they asked me to answer with positive exponents. So that's easy enough. All I'm going to do is move the x to the 14th power to the denominator, but don't forget to put that 1 on top, right? We need a placeholder for the numerator. The negative sign here told me that x to the 14th power needed to be its reciprocal, so it needed to move down to the denominator in this case, and then I'm done. All right, this one's tricky. They're trying to get you to just cross those out and say 1, but that doesn't work because I have x to the positive 6 in the numerator on top. I have x to the -6 in the denominator in the bottom. So that will not work. I need to go, well, I have two choices. Let's do, well, the way I would do it, we'll start that way, is I would go ahead and move my negative exponent here, negative exponent. Okay, and so I would have the x to the 6th power that was already there in the numerator, and then I'm going to have multiplication, and then this x to the 6th power is going to move next to it. Technically, I have a 1 in the denominator, but we're not going to leave that when we put the answer. So now I can go ahead and use product rule because these are side by side. That's going to give me x to the 12th power. And I'm good to go. I'm not going to leave that 1 in the denominator. It's implied. Okay, let's try another way. So another way to do this, we just have to be careful with our signs, is to go ahead and use quotient rule. Because it's division, I can use quotient rule. That means that I have to subtract, but be very careful. I'm going to subtract a -6, right? And so that's actually adding. And that gets me to the same answer. So I don't usually do it that way because I've been known to mess up my negatives, and I have to remember that I'm subtracting a negative and changing that to a positive. So I usually move all of my negative exponents first and then see what I have left. All right, again, more complication. There's a lot going on here, but we're going to take it a little at a time. But personally, I'm going to take care of that y to the -2 on the bottom first, and I'm going to move that. The rest have exponents that are positive. So that's going to give me 39 x to the 3rd power, y to the 3rd power. On the bottom, I'm going to have 6x to the 7 power. And then that y to the -2, I'm going to move that up here. Okay, so I took my negative exponent, and that told me to move the y squared to the opposite of where it is. If it's in the bottom, I move it to the top. If it's in the top, I move it to the bottom. Okay, and so also now that is a positive 2 because I moved it. Okay, so let's attack this thing. The very first thing we're going to do is only look at the numbers. So 39 is not divisible by 6. However, I could reduce that a little bit, right? Because if I have, they're both divisible by 3. And that's going to give me 13 over 2. So 39 divided by 3 is 13. 6 divided by 3 is 2. Okay, so I'm going to have 13 on top with some other stuff, and then I'm going to have 2 on the bottom. Okay, let's see what we have here. So with the x's, I have x to the 3rd power and then x to the 7th power. Oh, so this is the first time that we've had more x's left on the bottom. So there's a couple things we can do. Let's look at it up here. If we have x to the 3rd power over x to the 7th, technically we use quotient rule and we subtract these, right? But if we do that, we get x to the negative 4. And we know that they're not going to let me leave a negative exponent. And so that would be 1 over x to the 4th power. Now, let's look at this another way. Because I have more x's on the bottom, remember how we were crossing out the x's because x over x was equal to 1? Well, we can see that we have 3 x's on top and 7 x's on the bottom. So 3 of those x's would actually cross out and we would have 4 left, but the 4 would be left on the bottom. Okay, so whichever way works for you, you're welcome to just use quotient rule, get a negative exponent and move it, or you can think about, like in this case, the x's are bottom heavy. We have 4 more on the bottom than we do on the top. And so what that tells us is that we would be left with x to the 4th power on the bottom because those 4 extra x's would stay put. Okay, and then finally I have my y's. I have y to the 3rd times y squared. So that would be product rule. And that would give me y to the 5th on top. And then I think I'm done because I can't mix up the x's and y's. Those are different bases. The numbers are as simplified as we can get them. And so we're going to stop right there and put that into our answer box. Wow. Okay, I know it looks terrible, but let's use our order of operations. So order of operations tells us clean up what's inside first. So we're going to do that first. So let's take a look. We have, well, let's look at our numbers first. We have negative 14 over 7. So that tells us that we have a negative 2, right? 7 goes into 14 2 times. We've got a to the 3rd power over a to the 10th power. So we could subtract a to the 3rd minus 10 would give me a to the negative 7, but then we'd have to move the a down. Or because we can see that we're bottom heavy, we have 3 a's on top and 10 a's on the bottom. And that means we have 7 extra a's on the bottom that are going to have to stay put down there. Okay, then we have b to the 2nd power and then b to the negative 7 on the bottom. So we have a couple options. Let me go ahead and I'll move the, so I've got b squared times b to the 7th power. And what that would give me is b to the 9th power on top. Right, 2 plus 7 gives me 9. Now, all of this is going to have to be raised to the 3rd power. Okay, and so we didn't really do power of a quotient rule, but that is the same idea. We can write it right here. So power of a quotient will work the same way. If we have x over y raised to the power of m, you're going to get x to the m over y to the m. So it's still kind of like you're distributing that exponent. So let's go ahead and do that. We have -2 raised to the third power. Remember, you have to use parentheses. Then we have b to the 9th power raised to the third power. And then finally, don't forget the bottom, you have a to the 7th raised to the third. Okay, so I took each of these. I took -2, raised it to the power of 3. We're going to pop that in our calculator. I took b to the 9th power raised to the third power. And then finally on the bottom, I took a to the 7th power raised to the third power. So now we're going to clean all that up. I'm going to put that up here. So -2 raised to the third power would be -2 times -2 times -2. So that's going to give me -8 in the numerator. Then I have power rule here. Whoops. So when we raise a power to a power, we multiply. Therefore, on top, I would have 9 times 3, which is 27. So b to the 27 on top. On the bottom, 7 times 3 is 21. So I would have a to the 21 on the bottom. And then that's all I can do because we have different bases. Okay, so again, you have to be really careful because the numbers have different rules than the variables. So you get really caught up in the variables, and you know if you raise a power to a power, you're going to multiply, but that's not true for the number. You don't want to multiply -2 times 3 because technically there's a 1 sitting here as an exponent. So that would be actually 1 times 3 would give you 3, and so you'd have -2 raised to the third power. But be very careful, make sure you use parentheses. Okay, let's do a quick review. So product rule means that we have two variables multiplied together. The variables have to be the same. We have to have the same base. If the variables are the same and it's multiplication, so x raised to a power times x raised to a power, we can add the exponents. Oops, I forgot quotient rule. Let's put quotient rule up here. So quotient rule is the same idea. We have, except it's division. So quotient means division. And again, the bases have to match. If they match and we're dividing, then we're actually going to subtract. Okay, so product rule, we're multiplying variables raised to a power. We're going to add the exponents. Quotient rule, we're dividing variables with an exponent, and so we're going to subtract. Power rule, we're raising a power to a power. When we do that, we actually multiply the exponents. I don't know about this stylus. All right, so m times n. Let's look at power of a product. So power of a product means that you have two items multiplied inside. So product rule is multiplication, but then you're raising them to a power. And so you're kind of distributing that exponent across all of your items inside the product that are inside the parentheses. Quotient rule is division. So that would be if x is divided by y and raised to the power of n, then you would get x to the n divided by y to the n. All right, negative exponents. So let me kind of make a little barrier here. I'm going to do this too so that I have room. All right, so for negative exponent, if we have x raised to the negative m power, that's going to become 1 over x to the m. Remember, it's movement. So if it's in the numerator, which if you don't see a fraction, you know that it's in the numerator. It has an implied divided by 1 underneath it. So if x to the negative power is in the top, in the numerator, you're going to move it down to the denominator. If it's the other way around, where the negative exponent is in the denominator, then you're going to move it up to the numerator. And again, you really do have that implied 1 underneath. We just don't write it. Okay. And then finally, we have the 0 exponent, where anything raised to the 0 power is equal to 1. And of course, I didn't prove that, but let me show you really quick. So if I had x to the second power divided by x to the second power, well, those are the same, right? Just like 2 over 2 is equal to 1, x squared over x squared is also equal to 1. Okay. Well, you say that didn't prove anything. Well, let's use quotient rule. Quotient rule tells me that I can subtract these exponents. So x to the 2 minus 2 would give me x to the 0. Well, if this one is equal to 1 and this is equivalent, then this one is also equal to 1. Hence, x raised to the 0 power is equal to 1. So that's a very important concept that you need to know. Just kind of have it in the front of your head.